this is Mr. V. In this video, we will determine the area of a complex compound shape. We want to calculate the area of this composite shape. And we've got a few things going on. So it is fairly complex. To begin with, we can see that we have these mixed units. We have centimeters, we have millimeters, we have meters, and we can't do that. They need to be the same unit for us to do this work. So we're going to start by just converting all of the units so that they're all in the same form. And I might just pick meters simply because that seems to give us some whole numbers here. But you can pick any. So I'm going to change 400 centimeters into meters by dividing by 100, which gives us 4 meters. And with the millimeters, 6,500 millimeters, that is divided by 1,000 to give us 6.5 meters. Not a whole number, but halves are easy to work with. And that's all of my units now in meters. So we have meters, meters, meters. And now we can start with our usual process of identifying areas. So if I'm looking at my shape over here, I can see I've got 3 areas. I've got this triangle, let's call it area 1. I've got a rectangle that goes around here. And then I've got this half of a circle, this semicircle that we're taking away. Now, one of the problems we're having is we're not exactly told all of the measurements. So we're going to have to go through and figure some of them out. If we're looking at our first area, the triangle, what I'm just going to do is I'm just going to quickly scribble it down. So I'm going to quickly draw my triangle. The drawing doesn't have to be perfect, just as long as it gives us the information. And just by looking at the diagram, I can already tell the base here is 12 meters. So that's nice, 12 meters down the bottom. But how tall is this triangle? Okay, we're not told it. We're told how long this part is, because that's just how high this circle is, which is the radius, which is 400 centimeters or 4 meters. And we're told how high it is from the bottom right up to the peak, but not the difference. But that's easy to figure out. This difference, this part in here, is 6.5 meters minus 4 meters. Okay, quick math, that's 2.5 meters. All right, now we've got all the information we need. So the area of the triangle is a half base times height, and that becomes a half times 12 times 2.5, which is 15 meters squared. All right, now we're going to do the same for the next area. Let's make that our rectangle. So we're looking at our rectangle. Looking at a diagram, the height of this rectangle, or the width, whatever you want to call it, is the same as the radius of this circle, which was 4 meters. So I can write 4 meters. And the length of the rectangle is the same as the base of that triangle, which is 12 meters. So we're using a bit of reasoning here to try and figure out what those measurements are. So area 2 is a rectangle, so length times width. And to calculate that area, we are multiplying 12 by 4, which is 48 meters squared. Easy enough. All right, and lastly, we are looking at this semicircle, this half of a circle. And the radius of that circle was 4 meters. We've already dealt with that one now. The area of a semicircle is pi r squared. And because we only have half a circle, it's divided by 2. So pi times the radius squared, which is 4 squared, divided by 2, which is 25.13 square meters. Our last step is to calculate the total area. And looking at a diagram, that's adding the triangle and the rectangle. So it's 15 plus 48. And then we're subtracting the circle, which was 25.13. That almost out of space here, not quite. That is 37.87 square meters. And that's the area of this complex composite shape. Fantastic.